I just love doing all this sort of thing. I mean, learning about all sorts of stuff is amazing.
Yep.
Yeah. If I'm not learning, I'll be dead.
That's good. And you're building your electric dream machine.
Yeah.
It just happened to be a Sydney Ferry. And it's awesome. Right, okay, inverter time.
Yeah,
Tell us what you have been doing. This is amazing.
What I did was I took the entire wiring harness out of the car.
You can see it.
And
it just goes
almost everything that it connected up to. So,
anyone want some Hyundai bits? We've got a lot here.
Yeah, so the first problem I had with that was that I didn't have an ignition key or fob, so I couldn't switch anything on.
Yep.
So I ended up hacking into that, and I found a couple of relays, and I put power supplies onto those. And I managed to get everything working: the instrument panel, the navigator. So I got everything to work.
That's great.
And then I started with the inverter. So
let's have a peek inside.
This was all silicon on. So I had to cut that with a blade and then start trying to figure out what on earth all these little things did. Anyway.
So tell us what you found.
So
you made some great progress.
I did manage to figure out more or less that this was the main control board. This is the gate driver board underneath here that controls the motor speed and direction. And I managed to hack into that with these wires and those light bulbs up there.
as a bit of a load.
Yeah. So
instead of plugging it into a motor and blowing something up.
What I did was I put, I used an Arduino, which is one of those, and I fed a signal in to those, and I got the IGBTs, or the big power transistors, to switch on those lights as a result of the signal from...
IGBTs are under here.
Yep.
Yeah, you can see the DC from the pack coming in here, and then the three-phase coming out to the motor.
Yeah, so these IGBTs are all water-cooled underneath.
Yep.
And that's where the big plug that you saw earlier on plugs in.
The big orange. And then you said this was the...
that's current transformers.
For measuring...
measuring the current, yeah. And so what they do is they only measure two, and with those two measurements, they can calculate the third.
Yeah. Clever.
So I've still got some work to do here. This is the open inverter control board.
Yep.
That's the mini, and I've got to figure out all the connections to drive the IGBT. So I'm basically breaking in between the original control and the IGBTs.
So you pretty much won't be using the brain board here.
No, the only thing I'm using out of this brain board is the power supplies and maybe the signal from the current transformer. Yeah,
that's cool. But and then just talking and using the open inverted board to drive the control board, power control. And then under here was the
so that's a DC to DC converter. Yeah.
I'll let you do that.
It's worth looking at because it's so beautifully made.
They really
it's just fantastic
device.
So this area here is the high voltage. That's 320 volt DC.
Not powered at the moment.
No,
you wouldn't want to do that.
No. And then it goes through switching controller and powers charges the battery. So this is quite interesting because this is rated at 150 amps.
That's pretty good
to charge the battery.
Yeah, that's great.
Yeah,
we've been talking recently about putting in small AC inverters into the cars because the DC to DC inverters are high enough power that you could run a little, 1 to 2 kilowatt inverter sometimes off your 12 volt battery because the DC to DC converter can supply that. And you can have a little emergency or utility
Yeah.
power supply for your battery. It's very cool. Yeah, and it is really well built. So, I mean, Hyundai have really done a good job in design and construction here.
Yeah, so this whole thing, and this is a 6.6 kilowatt battery charger underneath.
Yep.
And this is the distribution, high voltage DC distribution box. So battery power comes in here and gets distributed to the various parts where I'm not having the air conditioner anymore, but that's where all the high voltage DC gets split up. So there's the cooling pump just underneath here, and this whole system will bolt straight on top of the motor as it did it with the car.
Yep.
And it just fits straight on top of the motor. I've made some brackets where the chassis of the car is not anymore, so I've made a couple of brackets, and it all bolts straight down there. But it's too difficult working on it. That's why it's up here.
Yeah, definitely.
Yeah.
It's a bit filthy down there as well.
Yeah.
Okay, so here we are. We're going to have a look at the mechanical and the drive system of the boat, which is down in here. And you just talk us through it, Steve, and I'll try and point at various bits. And we decided not to crawl down in there, so we can do that.
Yeah, so, well, that's the IONIQ's drive. The inverter's got to come on the top of that, but that's the motor itself there, and attached to that stainless steel frame, I suppose, that's sitting on the original timber engine beds.
Yep.
So
the bedding timbers. And the original motor, you were saying, went right back up towards where those parts of the table.
I suppose to just past the front of the table.
Yep.
The original engine.
And came up to about here, and then the gearbox went from here to here.
Yeah, so
another bit less than half a tonne in the gearbox.
Yeah, 467 kilos of gearbox.
Yeah. We'll call that half a tonne.
And about 1,500 kilos of Detroit engine.
2 tonne of drivetrain being replaced by this roughly 100 kilo or so drivetrain.
So just to give you an idea of the difference in power, the Detroit was 110 kilowatts, and this IONIQ motor is 88 kilowatts.
Yeah, you can see the motor's here, and then there's a reduction. And what's the reduction on that final drive there?
There's a 7.4 reduction ratio, and then if you can see the shaft, the drive shaft comes out and goes underneath where the big orange cable is, and connects up to the prop shaft through a thrust bearing, and the other drive shaft, other end of the diff is just in place there, but I've welded the diff up so that, because we don't want the diff on that drive shaft. So
you can see the cooling heights of the motor, the old motor mounts, and then obviously the big orange high voltage input. And what have you done in terms of your adapting? That looks like a wheel rotor.
Yes, that's I've used the front wheel bearing set up from the IONIQ as a thrust bearing, and I've mounted that in a stainless steel plate that can move up and down in that sort of housing.
Yep.
And the whole housing can move left to right on slotted holes that bolt to the main bracket.
Okay, so you can tweak the alignment.
And then the coupling, very, very kind of IONIQ to make the disc rotor of the front wheel almost exactly the same diameter as the coupling on the prop shaft.
On the prop shaft. That's
so. Yeah, so I got the laser cutting guys to cut out a template, and I drilled holes through the disc rotor so that it would accept those 1-inch bolts that go through and fix it to the coupling.
It's very cool. So now you would tell me a little bit about how much power the motor's got, but now how much power are you going to need? What will, like, you know, the original motor, how fast the ferry used to go?
Yeah, so basically the hull speed, which is about 10.4 knots, needs about 156 or 150 horsepower to drive it at hull speed. I'm not going to be going anywhere near that, I don't think. If I'll be over the moon if I can run it at 8 knots. And for 8 knots, according to the Vic calculations, we'll get 8 knots at about 60 horsepower.
Okay.
So
about 50 kilowatts or something.
6 knots drops right down to 26 horsepower. So
yeah,
I think battery capacity, which is going to be very small initially because of the cost of the batteries. I'll build that up over a few years. But yeah, so we'll be going short trips initially and longer trips later.
Yep, that's cool. And when you get your 5 kilowatt of solar, I mean, I guess you could theoretically do a couple of knots at 5 kilowatts. That really you could just tick along,
probably,
potentially.
Yeah.
And always
so, yeah, so I haven't actually looked at those areas too closely as yet because it's going to be, you know, the theory, however much theory you put into it, it's not going to be like that.
Yes.
We're going to have to suck it.
That's right. And so, because there'll be losses here in this drive system that are unknown at the moment, and in what condition the bearings further along are, and
yeah. Well, they are pretty good because I've kept them greased.
Yep.
And
you can see under the floor. This is a very long drive shaft. How long did you say that was?
7.2 meters.
7 meters of 3-inch drive shaft with multiple bearing points on it. So it's unknown. Yeah, unknown still to be.
Yeah, well,
tested with actual real world.
The good thing about it is that it actually I can turn that with a wrench quite easily.
Yeah,
it's been I just love doing all this sort of thing. I mean, learning about all sorts of stuff is amazing.
Yep.
Yeah. If I'm not learning, I'll be dead.
That's good. And you're building your electric dream machine. It just happened to be a Sydney Ferry. It's awesome. It's great. Well, thank you for that. And we'll look forward to hearing some updates
that'd be
in
great.
the years ahead.
Yeah.
Months, years.
Yeah. Well, it's been a pleasure having you here, Doug, and thanks for doing the video.
It's great.
I'm sure we'll stay in touch and keep the knowledge pool growing.
Absolutely. That's what beautiful thing about the EV community is the sharing of information.
Yeah.
Cool. All right. Thank you, everyone, for watching, and we'll catch you next time.